One, two, three. Yes, perfect. Thank you. Okay, guys, let's get this started. Welcome to the session about how about deploying your SDDC lab in about an hour. So this is going to be about SDDC lab. It's a project that I've been working on together with my partner in crime, Louis Chanu. Currently, we're at version 7. More about that in a minute. So it's a project, like I said, we've been working on for a couple of years. I think we started back in 2020 in the middle of the pandemic. We had some time to spare. And yeah, we just kicked off this project. We felt the need for automating deployment of nested lab environments. Luis is not able to be here. He was with me in Las Vegas for a month ago or 2 months ago, but unfortunately he couldn't be here today. So let's have a look at what is SDDC Lab. So if we look at what is the project, so it's basically we provide you a way to spin up nested VMware SDDC environments, and we call those environments pods. And we use Ansible as the scripting engine to get these pods in place. So it's basically a bunch of Ansible scripts that are running in a specific order to get a environment in place. And well, the use case for a nested lab is like any nested lab. It's for learning purposes. It could be for development or testing, or you maybe have a proof of concept that you want to conduct and you don't want to do it in your test or your physical production environment. So you can just spin up a SDDC pod and get started. So what's unique about this project? A couple of things I want to point out, because there are a number of these projects around. Obviously, we have William Lambs and we have some other people doing things with scripted lab installations. We believe that what's unique with our setup is that we can consistently deploy nested lab environments consisting of all of these products. So vSphere, vSAN, NSX, Tanzu, Area, and it's all configured for you. So it's nothing like we deploy the products and then you have to start configuring them. It's like we deploy the products, we configure them, and you can immediately start working on doing your testing or you're using it for your use case. The other thing we have been spending a lot of time on is to be able to connect those environments to your existing network. So these networks, these pods can connect using a pod router to your existing lab or production environment, which means it's a bit easier for you to get into it. You can share the environment with other people in your organization. You can do ordinary administration through SSH or APIs. Using one of the routing protocols, BGP, OSPF, or static routing. We also use the original installation media, so we don't use any custom OVAs or anything like that. You just download the media from Broadcom, you download it into your jump station, and you're good to go. The products are installed from that media. We also make sure that most of the components are configured the way that VMware or Broadcom is recommending you to configure them as. So you get an environment that's quite similar to a production environment. So let's have a look at what is kind of the infrastructure to create a SDDC lab pod. So it all starts with a Ansible controller. It's a Linux machine of the one you prefer. It's not tied to any specific distribution. You can use Red Hat or Ubuntu or anything like that. You install the Ansible software on it. You need a physical layer 3 switch. Most of the times, at least we recommend that you use a layer 3 switch in your lab environment. And you need a DNS server as well, because several of the components inside an SDDC lab pod need DNS resolution. So you need this DNS server somewhere in the backend. What you then do as the next step is create a VLAN, which is called the router uplink segment in our lab environment. So this VLAN is kind of the interconnect between your SDDC lab pods and your physical environment, or the environment outside of the pod. So as you see here, this VLAN is used to do peering for BGP or to create OSPF relationships or to do static routing. It's kind of the uplink to the physical environment. And your physical layer 3 switch will obviously have a gateway address in that VLAN. Now, The first thing that we can deploy for you is a DNS server that is completely pre-configured for a SDDC lab pod, or pods, I should say. So this DNS server will be authoritative for the SDDC lab domain. It will have the forward and reverse lookup domains for IPv4, IPv6, and it will create a lookup or a recursion relationship up to your public or your corporate DNS server. Your corporate DNS server could then have a conditional forwarder to do resolution into the pod lab. The next step when deploying a pod is the pod router. So this is the counterpart of the physical layer 3 switch. The pod router is configured to either do static routing, BGP or OSPF in that uplink segment towards the physical layer 3 switch. And then finally, once the routing and the connection is in place, we have the pod itself. So the pod itself is like I said, a nested environment containing ESXi hosts, vCenter, etc. So this is where they live in their own small bubble, so to say, and connect to that pod router, use it as the default gateway. You're not limited to one pod. You can spin up kind of as many pods as you want. A little bit more about that later, but you can run several pods in parallel, which makes it possible for you to test out different scenarios. Maybe you want to do some multi-site scenario. Maybe you want to do some NSX federation. These pods by default can communicate to each other as well. The routing is all done in the uplink segment. So yeah, it's kind of mimicking a multi-site environment if you spin up pods like this. Obviously, you don't have to communicate between pods if you don't want to. So what's in a pod? Well, we have the pod router. It's based on iOS. It's a software router, a virtual machine. We have a vCenter server. We have ESXi hosts, obviously, organized in clusters. We use vSAN storage for the storage. Optionally, you can also mount a NFS storage in there, but by default it's vSAN. You get an NSX local manager, fully configured with edge nodes peering to the pod router, and you also deploy operations for logs. On top of that, you can enable some additional components. So you could, by just modifying the configuration file we use for deploying the pod, deploy this DNS server, like I mentioned before. I highly recommend that you actually do that, because if you don't, you need to do a lot of things in your existing DNS server that you might not want to do. So have that DNS server there dedicated for the pods is a real good thing to have. You can also enable advanced load balancer, which is then deployed, fully configured with NSX, etc. We have the vSphere supervisor, as it's called today, I believe. We have NSX federation, so you can do federated. We set up a federated topology for you, consisting of multiple pods. Enhanced link mode, we do IPv4, IPv6 in the NSX overlay segments, if you want that. And recently we had a contributor called Aaron Ellis. He's a great guy, has been working on a playbook or a script for the SDDC manager UVA, so that's also possible to enable, and you'll have an SDDC manager in your pod. And of course, the way things are going at VMware or Broadcom, we all know it's a lot about VCF. So we want to look into doing a VCF brownfield import at some point in time. That feature is not yet available. It's coming in the next version. Quickly about the version. So what can this thing deploy? Well, we constantly test out the scripts. So they work with the latest versions released by Broadcom. So this is kind of the latest versions, I believe. Maybe there's some newer for some products, but yeah, we try to keep up. What we've noticed is that the scripts we created back some years ago actually still work for the most part, or they actually work without having to modify them with newer versions. So yeah, as you can see, latest version of vSphere, NSX, Advanced Load Balancer, SDDC Manager, etc. So networking is something we have been spending a lot of time on. So what we've come up with is that every pod gets a unique pod number, which is divided by 10. It goes from 10 up to 240, and well, there's always a gap of 10 between each pod. And this is done to keep the pods unique, because this pod number is driving all the networking inside a pod. So we derive IP addresses, network, VLAN IDs, autonomous system numbers, etc., all from this pod ID. So that's the reason behind it. So yeah, you could have, if you quickly calculate, you could have about 24 pods running in a specific subnet. Then you need to go to the next subnet, just to keep it unique and to be able to run them in parallel. At the heart of each pod, I mentioned it a couple of times now, we have the virus router. What's the function of that one? Well, it's like any router really. We have this guy routing the lab networks in a pod to the north, to the outside world. And we also use it for connectivity back to the pod networks and the physical network. So really a standard routing function. A quick overview of the networks inside the pods. So the way we've carved out the VLANs is as follows. We have about 10 VLANs, or we have 10 VLANs in each pod. I think you'll all recognize those VLANs. Nothing really strange here. Some of them are not in use, like IP storage is not in use. Service VM management is not in use, but you could start to use them whenever you feel like there's a use case for it. So there are some VLANs there that are not being used. Obviously, this is completely configurable. If you feel like I don't want to do anything of this, or I don't want to do IP storage, you can use that network or something else. It's nothing that you have to use. So when it comes to the physical ESXi host or host that this is running on, as I mentioned, it's a nested deployment. So we run ESXi virtual machines on a physical ESXi host. If you have just one ESXi host, it's pretty simple. All the VMs will be running on that host. You don't have to think about VMs moving around in the network. It's all quite simple. There's going to be we're going to build a SDDC Lab VDS switch for you, and that one is doesn't require to have an uplink to the physical network really, because everything is done within the host anyway. Now, most people have multiple hosts in a lab, and that's a scenario that's also we want to, of course, handle. Then there's two options. Either you use two scenarios more. Either you have a large layer 2 switch with enough ports, so you can just connect all your ESXi hosts to this switch. You also need to create the VLANs, obviously, that you use in the pod networks. So if you have 10 pods, then you need to create all those VLANs. It's about 30 VLANs. If you don't have the ports available on your layer 3 switch or your router, you could do a classic layer 2 switch, connect your ESXi host there, and just use the layer 3 switch for the routing. Just to visualize that a little bit more. So on the right side, we have your existing lab VDS. That one has one interface of the pod routers connected. On the left side, we have a SDDC Lab VDS. That's the one that we create with our scripts. And each router has an interface into that switch as well. In this diagram, we have both a layer 3 switch and a layer 2 switch. Obviously, you could stretch that layer 3 switch if you just have enough ports, or you have a switch that can handle routing. Just a quick overview. And then you would have all the VLANs for all the different pods created in that switch. So this is the core networking part of how you handle the physical and virtual networking, so to say. All right, so when it comes to configuring the pod, we have a couple of configuration files that you should be aware of. Those are listed here, 4 of them. The most important one is actually config sample YAML. We have a licensing sample YAML, we have a software sample YAML, and a template sample YAML. These are in the repository at GitHub. So when you clone the GitHub repository, you will get those files. And what you can do is use them as a kind of a baseline for when you start deploying your first pod. So you just copy those sample files. They need to be called like that, except for config. And then you can start making your modifications. So a little bit of more of a look at the config YAML. It's like I said, it's the blueprint of a pod. It will contain every setting of every component in a pod, all the way from your physical ESXi down to the overlay networks of NSX. It's a huge file. It has a lot of lines of code. But yeah, like it says here, what we recommend is that you kind of keep it to a minimum when it comes to changing your settings, at least from the beginning, because it can get very overwhelming after a while. So there are a couple of settings that are essential. I would say that those 10 settings here are the ones that you need to modify probably. So you have probably a password on your physical ESXi host or your vCenter server. We don't know what that password is, so you need to enter it in the configuration file. You might have an upstream DNS server that you want to use, or you use the pod provided DNS server, which in that case you don't have to change anything here. You might have an NTP server externally from the pod, or you use the one that is coming with the DNS server. Yeah, there are some other settings. You can see it for yourself. You need FQDNs, you need some IP addresses, you need to know the data center name, the cluster name, etc. So out of those 3,000 lines of code, you need to actually change only 10 to get started. And like I said, I recommend that you start with this and then you start experimenting the more comfortable you get with how this configuration file is built up. So just a small, to give you a small idea what this file looks like, it's a big YAML file, nothing strange. It's all organized in different sections. We use some ASCII art to make it very clear. Here I'm pointing out the password to the physical ESXi host or the vCenter server. Maybe your DNS server needs to be changed, and there will be some other settings as well. We have a special section for target config. Where do you want to deploy your pod? Is it on a standalone host or is it on a vCenter server? So we handle that as well. You could deploy it on a standalone ESXi host, or you could do it on a vCenter server. If on a vCenter server, we need to know some stuff about it, like what is the data center name, what's the cluster name, what's your data store name, etc. Also, you need this uplink to the router segment that I talked about before. What did you call that uplink port group? A little bit further down under the router, you can then configure how do I want to talk to the physical network from my pod. Either you do it with static, BGP, OSPF, or both, and both is OSPF plus BGP. So as long as you have a physical layer 3 switch that can talk BGP, OSPF, and it's pre-configured, you should be good. A little word about the software library, which is basically consisting of two components. On the left, you have the YAML file, and this YAML file is containing the definitions of all the products that the SDDC lab project can deploy for you. It will contain the metadata on which version, the path to where it is located. It's completely customizable, and maybe you already have a software library somewhere with all your ISO files or your OVA files. Make sure you just to update the path and you should be good. If, however, you like the structure that we suggest, you could use a utility that we created to create a software directory structure, which you see on the right side here. It will create a directory structure for you on your Ansible host with all of those paths, and the structure will be in place. You can just drop your ISO files and OVA files in it, and you don't have to worry about changing anything in the software YAML. But it's up to you. I prefer to have it as easy as possible, so I use the template that we provide. But if you have anything already, have something already, then it's fine too. So how do we deploy a pod? It's a two-step process really, and that has to do with Ansible not being very good at resolving variables, at least not when we have 3,000 lines of code. So we have a two-step process here. The first step is we take your configuration file, the one that you have created, so your config.yaml, you have made your modifications, pointed out all the right settings, and the first step is then to translate that config file into a static config file which has all the variables. That file then gets created. As you can see, the file will have both the date, the time, not the date, but also the different product versions that are available in your configuration. So you can create multiple configuration files, and you can see from the file name, okay, this is a pod that's going to have vCenter 8 update 3b. It's not going to have login site. It's not going to have advanced load balancer, etc. Just to make it a little bit easier for you to see, instead of having to go into a file and check what it is. So that static configuration file has all the variables translated, so it will have all the values in place, which means that in the next step, when we actually deploy the pod, that deployment process gets very lean. We don't have to do any You don't consume any CPU for doing the lookup on the variables. The command is displayed here. It's very simple. We use a YAML file which is called deploy.yaml, which is actually the orchestrator playbook, which deploys all the components in the right order. And yeah, you're using your static configuration file as an extra input. The -e there is used to feed the values into the process. So deploy YAML, which is calling upon all the playbooks, knows what to do. And well, just to give a small impression of what that looks like. I'm not going to, I promise I'm not going to stand here for an hour and have you look at the deployment, but we kick off the deployment. It starts to do some validations as well. We have about 20 or 30 validations. Because it takes an hour or a little bit more, it's not so nice to end up like after 45 minutes, oh, the ISO file for an NSX or the OVA file for NSX is missing. So we do some sanity checking in the beginning, just to make sure that you're not wasting a lot of time. After that, we start to prepare the physical ESXi host, the port groups. We start to push DNS records into the DNS server. And, well, eventually we get to the point where the first component is deployed. In this case, it's going to be the router. Yeah, it's not very interesting, but it's just going to rattle on here. Let's just see what happens. So these are all the DNS profiles, and here we start to check if the VIOS router is already there. If it's not, then we start to copy the VIOS file from their GitHub repository. So that's all done on the fly. You don't have to download that one in advance. And we start deploying the router. Hopefully, after an hour or so, in my lab, it was a bit more time, 1 hour and 20 minutes, 27 minutes to be honest. You get this screen, everything has been deployed. The 20 tasks that took most time will be displayed here. As you can see, the NSX installation was actually the most time consuming, and after that it was the vCenter deployment. Those two are the time consumers, so to say. So what do you end up with then? Always nice to have a look at the result as well. So let's have a quick look at the vCenter that just was deployed. So we have a pod here, 230. So the naming standard is also used by the pod ID. So we have a cluster that's called Compute A with a couple of hosts. We have an edge cluster with the ESXi host, the nested edge virtual machines for NSX. For storage, we're using vSAN data source, so one for each cluster. At this point, we're still using OSA vSAN. We're looking into doing ESA in a future release. And for the network, you can see we have some NSX segments here that are pre-curated as well. And we have some other port groups that you can use. For NSX, yeah, it's similar. We do configure some stuff in NSX as well. So we have a tier 0 router or gateway, which is paired with the VIOS router at the top there. Below the tier 0, we have a couple of tier 1s that we pre-configure. So we have actually have created two for advanced load balancer already, so that's prepared. Then we have one more general tier 1 gateway where we have the web database application segments. So, for example, if you want to play around with segmentation, that's already there for you. And then the uplink segments as well. Last but not least, we also generate a documentation file. So every pod gets this HTML file, which contains some data and information about the pod that was just deployed, timestamps, what was deployed, also links to the different interfaces will be there. You can just pick up this HTML file from your Ansible host and copy it somewhere. We have credentials there as well. It's a lab environment, so nothing really secret in there. And the VLAN IDs and the IP subnets that have been assigned to these VLANs. And that's pretty much it for me. Are there any questions, comments? Sorry, we need a microphone over here. Sorry. Yeah. So licenses, I didn't mention it, but licenses, we have a YAML file as well for that. What you can do is either you put in your license keys there, the ones you have for your environment, and we will apply those license files to your product. If you don't have any licenses, you can leave it as it is, and everything will be installed with the default trial period of what is it, 60 days? Yeah. So it's both is possible. Yeah. One more?
Just a question about how much memory you'd need on the physical host.
Yeah, so it's a good question. It depends very much on what you're going to deploy, but I would say for a default pod, the one you saw, I think you should have the minimum amount of memory you need in your host is about 256 gig RAM. So this is not going to work on a simple Intel or Asus NUC. You need something better, but you don't need anything like you don't need a real server, you just need something more powerful. Yeah, memory is often the constraint as usual, so 256 gig RAM. That's what I would recommend. Wait for the mic.
Okay, hello, thank you. Can you use the memory tiering, the new feature in, I think, version 8, update 3, so you can use an NVMe as memory extension?
Sorry, I didn't really hear what you said.
There's a new feature in the ESXi 8, which is called memory tiering.
Yeah, right.
And you can add an NVMe as memory.
It's something we're looking at because, yeah, that could be interesting to use for a project like this. Very good point. Thank you. All right. Thank you. Yeah, you have this game here going on, so if you're in the rewards token game, please scan the QR code here so you get your points. I'll be around here today somewhere, so if you have any other questions you want to take with me, then let me know. Thank you.